So a little bit on the background. Bird electrocutions and collisions are not new. They've been around since power lines have existed. Electrocutions were documented in the late 1800s, or excuse me, collisions and electrocutions in the early 1900s. But it really wasn't until the 1970s that people started realizing the extent of the problem. So APLIC is the Avian Powerline Interaction Committee. APLIC was formed in the late 1980s, initially to address whooping crane collisions with power lines. And how many of you know if your utilities are in the whooping crane migration corridor? Anybody? So a few of you. So it's definitely, a species that if you are in that area, you're probably familiar with it, and some of the ramifications if you did have a whooping crane collision. They are an endangered species. So APLIC was initially formed because of that, but has expanded quite a bit over the years to address electrocutions. Currently, some of our big topics are a lot of endangered species like whooping cranes, lesser prairie chickens, sage grouse in the west, and we continue to refine our guidance documents on how to address electrocutions and collisions. APLIC was originally 10-member utilities, EEI, Fish and Wildlife Service, and Audubon. We now have over 50 APLIC members. We continue to get several new members every year. EEI is also a member. APLIC is housed within EEI. EPRI is a member. The co-ops are members through NRECA and RUS. And then the Fish and Wildlife Service is still one of our agency partners. And we're trying to get a few other agencies in there as partners as well. Here's the APLIC member map. And so I'm not sure exactly which companies are here today, but I'm guessing there's a number of you that are APLIC members. Does anybody know, show of hands, if your utility is an APLIC member? So we've got a few here. And sometimes people think that bird issues are a Western issue. It's eagles in the West, and there's not problems in other parts of the country. Not necessarily true. I mean, I saw 2 bald eagles driving from Peoria down here yesterday. I mean, there's birds out here. There's hawks, there's owls, there's eagles, whooping cranes, prairie chickens. There are things that can cause outage issues and also should, be on your radar screen because of environmental regulations. As you can see on this map, I mean, APLIC has most of the country covered with the exception of, a little bit in the Northeast we're missing, but a lot of utilities, and we actually do have even a Canadian member, Altalink, as well. This year is APLIC's 25th anniversary, and so we're doing a number of things to celebrate that, and a lot of it is additional courses. So what I'm giving you guys today in 2 hours is a snippet of what we cover in a day and a half in an APLIC short course. We have an anniversary event that we're going to be doing in Washington, D.C., which is more kind of a handshaking with D.C. people, but we'll be having that in June to celebrate our partnership with Fish and Wildlife Service. And then APLIC meets twice a year. We have a spring meeting and a fall meeting. Our spring meeting's actually coming up in a couple weeks in Florida. If anybody needs an excuse to go to Florida, we've got an APLIC meeting there. It's going to be in St. Pete Beach. And then our fall meeting is going to be in Monterey, California, another great location. And those meetings have a day-and-a-half workshop. We have an open business meeting that's open to anybody. And if your utility is an APLIC member company, we also have a closed business meeting that's usually a full day. And we get into a lot of different regulatory topics. Definitely a worthwhile group to be engaged with. There's a lot of peers there that have a lot of good information sharing, a lot of things that you can talk about and get ideas on what's working, what's not working, and guidance. As far as just short courses, we have a number of them, and this is, normally we do 1 or 2 a year. This year we have a lot going on. So you can see again, Hawaii. We've had requests there because of some bird collisions in Hawaii. There's going to be an APLIC course there. We do have one coming up in Kansas in July. So if you like what you see here and want to get a larger version of it, the Kansas one may be a good one. We'll probably be talking about whooping cranes and prairie chickens in more detail at that one. We're going to have one in Utah in the fall. There'll be one in Texas in the fall also, and then in Rapid City, South Dakota. And if you go on the APLIC website, we'll have information on all of the upcoming events. So a few of the resources that APLIC offers, in addition to courses, we have a few guidance documents. There's an electrocution manual and a collision manual, and I'll pass these around. Feel free to take a peek at them. These are kind of the state of the art for causes and minimization dealing with bird electrocutions and collisions. The electrocution manual also talks about bird nests on facilities. And I don't have a ton of copies here, but I do have CDs that have the electrocution manual and the collision manual. If you'd like to take a copy, feel free. You can also download PDFs at the APLIC website or purchase a hard copy on the website. So one of the other guidance documents that APLIC has produced is the Avian Protection Plan Guidelines. And these are basically, an APP is a toolbox, or the guidelines are a toolbox that a utility would use to develop an avian protection program within their company. How many of you guys know if your company has an APP? Okay, pretty good number. So the APPs are going to vary. Every utility is going to be a little bit different. These are kind of the 12 key principles that could be included in an APP. Not every APP is going to have all 12. If you're just starting out and developing one, you may have a pretty simple APP. You may have a policy, you may have standards, and you may have a reporting system. And that's probably all you need to start out. Once you start doing that, you find out where your mortalities are, then maybe you'll implement more of a retrofitting program, and then maybe some quality control efforts, and it can build on itself. But you certainly don't need all of these in here. The idea behind the APP guidelines is that they are voluntary. There's no regulatory driver that says you have to create an APP. But if you have an APP, that's going to go a long way with the regulatory agencies to show that your company is being proactive to address bird issues. And many companies may have the components of an APP, but it's not packaged up in a little bow like an APP. You may already have standards. You may already have policies and procedures that you apply. And just putting it under the umbrella of an APP will give you kind of that additional proactive effort that you can bring to agencies, particularly if you are getting scrutiny from agencies over bird mortalities. I have an example here of one of our APPs within PacifiCorp. And I should probably back up and tell you a little bit about PacifiCorp if you're not familiar with the company. We are part of Berkshire Hathaway Energy. We just got renamed last week, so I'm still learning that one. But we are a sister company with Mid-American Energy. We operate as Rocky Mountain Power in Utah, Wyoming, and Idaho, and we operate as Pacific Power in Oregon, Washington, and California. So we have different APPs for our different geographic areas. This is one for Wyoming. It's pretty large, but that's because probably 3/4 of it is our standards that are attached at the back. So it really doesn't have to be this involved. I've seen APPs that are 5 pages, and I've seen ones that are a phone book. It really depends on what your needs are for your utility. So feel free to take a peek at that. Despite the differences in individual APPs, they're all going to have a common theme, which is really to reduce bird mortality and improve reliability, and also to reduce your regulatory exposure. Having an APP is not a get-out-of-jail-free card. There have been utilities, including PacifiCorp, that have been prosecuted for avian electrocutions, even though they have APPs. And I'll talk a little bit about the laws in a minute. But really, having that in place gives you some assurances, some protection, particularly if you're working with law enforcement or agency folks that are new to this as well. Having an APP will probably go a long way with those folks. APPs are intended to be living documents. They shouldn't sit on the shelf. You really should be looking at them over time, refining them and improving them as your policies, or excuse me, as your standards change, or as you get a better feel where your bird risk areas may be. A couple things about the APLIC guidance. So the books that are going around, the different APLIC manuals, these are just that. They're guidance and they're suggested practices. They're not standards, they're not a regulatory requirement at all. And a lot of times, wildlife agency folks get confused about that and they think you must follow the APLIC standards. Well, it's not like that at all. APLIC provides some scenarios, and I'll show you some drawings of different designs. They provide problems and solutions of typical designs. That may not be exactly what you see on your system, but the idea is that it'll give you the principles to then apply to what you have on the ground. It's certainly not a one-size-fits-all. You may in some areas, and we see this out in the West quite a bit, permit conditions. If we have lines on public lands, like on BLM or Forest Service or National Park lands, they will have as part of the right-of-way easement that our lines have to be built to meet the APLIC guidance documents. I don't know if you'd see that as much out here, being more on private lands, but you could see that coming from state agencies or Fish and Wildlife Service. So why do we really care about birds? Why is there so much focus? Well, the two main drivers are regulations and reliability. You guys are well aware probably of the reliability piece of it. Birds and animals can cause outages, can have significant cost to equipment, damage, impacts to customers, you know, a whole host of things, result in fires, you name it. The regulatory piece is another driver that has some pretty big potential costs associated with it if you are prosecuted for bird electrocutions or collisions. And this nest up here, this is a crazy one. This is an osprey nest up in Idaho. That line is not energized. I don't think that would probably be on fire if it was energized, but it gives you an idea of, you know, how messy some of these bird nests can get. So there's 3 federal laws that protect nearly all native North American birds. The Migratory Bird Treaty Act sounds kind of obscure. It's from 1918. It's an old law. But that is actually the law that can impact utilities more than any of these other ones, more than endangered species, because there's so many birds protected under that. Pretty much all native North American birds are protected under that law. So a gull, a crow, a blackbird, hawk, owl, all of those birds are protected under that law. Pretty much almost everything is covered under that law. Eagles are protected under the Migratory Bird Act, but they also have a second law that protects both bald and golden eagles. So if you have an eagle electrocution on your system, it's a violation of 2 federal laws. So pretty serious. So a lot of utilities take eagles a little bit more seriously than other birds, and the agencies tend to wake up a little bit more when there's an eagle kill on a line versus a hawk or an owl, not to say that those aren't protected as well. And then endangered species. And so again, whooping crane could be one potentially for collisions. There's not too many whooping cranes, so the risk of collisions is, you know, pretty rare, but it can occur. The other endangered species in the Midwest would be lesser prairie chicken, which is not necessarily going to be a concern for direct mortality for electrocution and collision, but when you're looking at siting new lines, say you're building a new transmission line, you're probably going to have to avoid prairie chicken habitat or potentially get a take permit if you're going through their habitat. So there's other things with endangered species to consider. When we talk about kind of the teeth behind these regulations, they do have teeth. They are strict liability laws, which basically means doesn't matter how or why a bird got killed. If a bird got killed as a result of your facilities, it's a violation of the law. So if a hawk gets electrocuted, it's a violation of the law. Technically, the way the law is written, if you drive home tonight and you hit a robin with your car, you violated federal law. That's how strict the laws are written. So what do you do as a utility? How do you deal with that? And it's really up to the agencies to decide whether or not they're going to enforce those laws. So to kind of get ahead of the curve, that's where it's beneficial to have an APP in place, to have some standards and policies and procedures in place to show that you're trying to make an effort to protect birds. You're not going to eliminate bird mortality on an electrical system. But as long as you make a concerted effort to reduce it, the agencies will probably take that in mind when they have, you know, their prosecutorial discretion. You look at the potential fines, they're huge. And I think these are probably higher than OSHA violations. I mean, there's substantially higher fine to kill an eagle, $15,000 under the Migratory Bird Act. Eagles, $200,000 fine for the first violation, $500,000 for a second or subsequent violation. So huge possibility of fines here, possible imprisonment, and this could go against a company or an individual. And so, for example, say your company has had eagle electrocutions and the Fish and Wildlife Service that says they're going to prosecute you. They could go after your company as a whole. If your company has a solid program in place and you had one individual that just went rogue on their own and didn't report birds or did something bad, they could go after that individual. And so it's important when you are implementing your APP to train your employees and let them know, you know, if you have policies and procedures in place that they should be following it, or they could personally, you know, be at risk of being prosecuted under these laws. And there's been a number of prosecutions. Moon Lake Electric, which is a co-op in Colorado and Utah, was the first one to be prosecuted back in the 90s. Pacificor, we were prosecuted over eagle electrocutions. PG&E in California was prosecuted. A co-op in Hawaii was prosecuted over collisions. Most recently, Duke was prosecuted at one of their wind farms for eagle kills. So it is something that the agencies do go after. And you know, a lot of it may depend on who you have in your area and what that person's, you know, the law enforcement agent, what their specialty is. And in some areas, you know, they're looking at industry. So any questions, not to scare you guys, but any questions kind of on the background of why the regulations? Okay. So the next piece I'm going to talk about is electrocutions on distribution. Why do birds use poles? Number of reasons. They may use them for hunting, for roosting, for nesting, for perching. In areas where there's not a whole lot of trees, they may actually provide them some shade from the sun or from the elements. And I mean, we're seeing this more and more. These are great horned owls nesting on a transformer bank. Sometimes they like the heat of the transformer cans. Nice place to sit or nest. So how can electrocution occur? Basically face-to-phase or phase-to-ground. So you've got, you know, phase-to-phase risk right here, phase-to-phase there also. Here you've got a phase-to-phase, the phase-to-phase, and here you can see the ground wire coming up, so phase-to-neutral, phase-to-ground risk there. Here's a few examples of common electrocution risk structures. Streamline or narrow profile, you've just got really tight spacing there. So you take a large bird like a hawk, an owl, or an eagle, they're probably going to be able to bridge between the conductors, and you could have electrocutions. Here we just have this is a 4-wire high, so again you've got a phase-to-phase or potentially a phase-to-ground electrocution risk. Equipment poles account for a disproportionate amount of electrocutions because you just have so much going on in a small area. So you've got a lot of potential points of contact, both phase-to-phase or phase-to-ground. And then steel poles, and I'll talk about these in a little bit, can pose electrocution risks as well. You've got your grounded pole, your conductor right there, so you don't have very much space at all for contact. And again, equipment poles, you know, are going to account for most of your risk. And so if your utility is just developing your APP and you're not sure where to start, it can be overwhelming. You know, how do you know where your bird issues are? Well, looking at your outage data is a pretty good start. And looking at equipment poles, you will get a lot of bang for your buck going out and retrofitting equipment poles. If you can identify equipment poles in areas where you may have some good habitat, maybe it's in an ag field and you've got some fallow edges and, you know, some trees, woodlots around that, probably a good area for hawks and owls, and you probably see some benefit there as far as mortality and outage reduction on those equipment poles. So for birds to get electrocuted, they have to make contact skin to skin. And so for a large bird like an eagle here, their feathers provide them some degree of insulation. So if you have incidental brush-by contact, wingtip to wingtip, those feathers providing insulation, you may not have an electrocution if the feathers are dry. If their feathers are wet, that increases the risk. They can be more conductive when they're wet. So you could have wet conditions, and we've seen this, you know, not too many cases, but where you may have a pole that's normally avian safe. Say you've got a wood pole and it's soaking wet and you've got a soaking wet bird, you may have an electrocution on a pole that normally is safe just because of the wet conditions. But really the most risky is the skin-to-skin contact. And so on a bird, these are called the wrists right here, and this is basically where their feathers come out of, but this is the outermost fleshy part. And so when we look at avian safe dimensions, we're not looking at the whole wingspan of the bird, we're looking at these skin-to-skin distances, and then also the height, head-to-foot, skin-to-skin distances. So APLIC dimensions are based on the measurements of eagles. And so for these eagle dimensions, APLIC in the guidance document uses 60 inches of horizontal separation and 40 inches of vertical separation for avian safe design. And that's both, it's not and or. Sometimes, you know, we've had folks that may be confused and think, okay, I've got, for example here, you know, I've got my 40 inches of vertical clearance. Well, this is a steel pole, you don't have 60 inches of horizontal clearance. So that would not be avian safe. Here you've got both. So you need to make sure you have both dimensions there. You may not have eagles in your area. And I would caution you to just assume that, hey, we don't have eagles in our area, because eagles, particularly bald eagles, their range is expanding, their numbers are expanding. You may not have them throughout your service territory, but if you have areas that are along some nice river bodies and you've got some nice riparian habitat, old trees, you may have eagles there. So I would take a look at those areas, and maybe you don't need eagle framing system-wide. If most of your system is not in eagle habitat, maybe you have a separate eagle standard in those areas where eagles could occur. In other areas, so say your largest birds are hawks or owls, you may base your dimensions on hawks and owls. And in the electrocution manual that's going around, there is a table where we measured different species of birds, and it has some dimensions in there. So if you don't want to use eagles for your standards, there are measurements for other birds that you can look at. In some areas, like in Florida, where they have colonial water birds, which are basically like herons and egrets, they're really tall, they may have to have increased vertical separation. In other areas like California, where there's condors that have an 11-foot wingspan, it's a whole other problem. Having that large of a separation is pretty much not feasible in most cases, so you're looking at probably a lot of covers. So how do you get your avian safe clearances? There's two primary techniques, insulate or isolate, and we have insulate in quotes because the products that we're talking about are cover-up products. They're not true insulation. They are not rated for human protection. They're a cover-up, but insulate or isolate is kind of easy to remember, but just keep that in mind that these are just covers, not true insulation. Most of these covers are rated up to just 35 kV, so if you are looking at subtransmission, you're going to be looking more at framing out than doing any covering. So the next section here, I'm going to show you some examples of problem designs and solution designs and some avian safe new construction designs. These are pulled out of the APLIC document, so these are a few examples. There's a lot more in there, but I kind of took a few common ones. And in all of these, when you see the green, that's grounded, red is energized. So on this structure, we've got a single phase. We've got our ground wire coming up the pole, neutral below, but we've got our hardware bonded and grounded. So you've got a potential point of contact phase to ground on the top of the structure. So a few solutions. Probably the simplest solution is to put a cover up there. You would keep your bonding and grounding and just cover that phase up top. If you didn't need the bonding and grounding, you could remove that and just bring your ground wire down to the neutral. Now you have your 40-inch separation. You've got plenty of space there. Say you have a single phase with a cross arm. In this design, you've got your neutral up. You still have your ground wire going up. So you've got a phase to ground contact here or a phase to ground contact there. Coupled solutions, again, cover is probably going to be the most cost-effective option, just putting a cover on that energized conductor. This other scenario here, the cross arm is lowered, but you still have this potential point of contact with the ground wire. So some type of covering is put on the ground wire, and you could use molding for that. You could use hose, or you could change out a section of the ground wire with a covered wire. And in the APLIC manual, not every solution may be something you would use, but they've tried to show different scenarios, because when you go out and you look at a pole, you could have 10 engineers look at a pole and have 10 different ways to retrofit it, and they could all be right. So it's not necessarily that there's one right way to do it. Really looking at the dimensions, the 60-40 are kind of the key numbers to keep in mind, and if you've got those in mind, you can find different ways to retrofit. So moving on to three-phase. These are some common configurations. On the left here, we've got two conductors on one side of the arm, our neutral and ground wires down below, so we don't have a phase to ground risk, but we've got phase to phase. On this one on the right, we do have the ground wire coming up. Hardware is bonded and grounded, so we've got phase to ground risks and also phase to phase risks. So a few options. On this one, pretty straightforward again, cover the center phase. You don't need to cover all three phases because your outer two phases are plenty far apart, so really you're just looking at the center phase. On this one, if you do want to maintain your grounding and bonding, then you would have to cover all three phases on the cross arm.
Do they ever land in between poles though?
On the actual conductor? They can. I mean, it's not too often, but yeah, birds certainly can. And that's something, and actually that's a good point like for compact design. Because if you've got a design like this, you've got really close spacing, you can try to put covers on it, but if you did have a bird try to land on it mid-span, you still could have contact, yeah. So framing it out is definitely going to eliminate that. The risk of birds perching mid-span and making contact is much, much lower, though, than it is on the cross arm. So on the compact design here, again, you've got your pretty tight spacing. In the APLIC manual, the option that's shown for retrofitting is using covers. And this is one that I don't know that we've been able to successfully do this in our company because our insulators are mounted on the side like that. And you really, to put a cover on sideways, the wind's going to catch that and you're just going to have a nightmare. So unless those are mounted perfectly kind of up and down like that, you're probably going to have a hard time putting a cover on. What we normally do in this design is probably change out the crossarm, which can be complicated because in a lot of the areas where we have narrow profile, it's usually pretty old construction, short poles, maybe 35-foot poles. We don't have the pole height to drop the crossarm. So we're looking at possibly changing out a pole, which is very expensive. What we've done to kind of find a middle of the road option is we've changed out with an 8-foot arm and then still put a center phase cover on that 8-foot arm. So you're keeping your original pole if it's in good condition, changing out the arm and still having to cover it. These are tricky ones to retrofit though, and these are areas where you may want to talk to manufacturers and see what products they have. So for new construction, like you mentioned, framing out is going to be the ideal, and most utilities are probably going to opt to frame out for new construction. Covers are a good solution for retrofits. They're cost effective, they're fairly easy to install. The problem is they've got a lifespan, you know, and it's something that you're going to have to maintain. It's an aftermarket product on your system. And so I'll talk more about covers in a little bit, but you really need to do your homework on what type of covers you use because there's a lot of manufacturers now of avian protection products. Some are really good, some are not as good. And so before you go out and put covers on wholesale, you really need to look at them and see, you know, what impacts they may have on your system and what's the appropriate cover for your system. So framing out new construction, you're going to eliminate the need of covers, a lot better solution where you can do it long term. So applic manual here shows for new construction, 10-foot arm lowered 21.5 inches, 9-foot arm lowered 33 inches, an 8-foot arm lowered 41 inches. One of the things that we found in our company was this drawing here shows that center pin right in the middle. If you look over here, you can kind of see this one is on the side, and so sometimes, you know, we'll stagger the pin location. Well, depending on the width of your pole, poles are either wide or skinny at the top, that can influence your separation here. So this distance here can be, if you have an arm like this, you may not have 60 inches here. You may have 54 inches. And on this side, you may have 62 inches. So you're not getting your full separation on each side. Plus, when you look at the width of that pole, it can change. So we went out, we had some eagle mortalities on poles that were lowered, but we weren't quite sure how far they were lowered. Guys went out and measured them. Turned out we had, you know, maybe 54, 55 inches. We went to Fish and Wildlife Service. They said, well, that's not 60 inches. So, okay, we got to do something about it. And so as a result, we wound up going through and coming up with new dimensions. And so we lower our 8-foot arms 4 feet and 3 feet for the 10-foot arms. So we know we have that 60-inch separation. So another common design is a double dead end. Here you've got basically your phase-to-phase contact on either side. Solution for this is you can cover that center phase, cover that center jumper wire. Again, you can use hose or covered wire for that. And then dead end covers on either side. And I think here's a picture of this installed. Here we've got the dead end covers. We've got covered wire. This one, they actually suspended the outer jumpers underneath, but you don't necessarily need to do that. One thing, when you are using on your insulators in the middle here, these are clamp tops, so we're able to just put the hose right through. If we have ones that we have to tie in, depending on your utility, our practice was that because of radio interference, we couldn't tie in the hose or the covered wire, so we'd have to skin that section. So if we do that, we'd wind up still having to need a cover on that center piece. So again, all the kind of little details that you need to look at when you're doing these retrofits. And these, I'm kind of getting into the more complex. When you get into dead ends, buck arms, corners, they can get a lot more involved in the retrofitting. For dead ends, there's a few things that you can do to bring that dead end out. You can use an extension link. You can add extra bells, which I don't have a picture of, but basically same idea. Instead of the link, you add extra bells, which we tend to do that more than the link because then at least you get the added insulation value as well. Or you can use a dead end cover. And dead end covers are fairly new. They've only been manufactured by, not all of the companies make them, but several of them do, but it's only been in the past less than 5 years probably. And again, these are ones that you should probably do your homework on. We've tried a number of dead-end covers and had successes with some and then problems with others. And so depending on the types of dead ends you have, you really need to look and see what fits for an automatic may not fit for a bolted dead end, or a lot of configurations out there. So here's an example of a corner pole. Again, problem design. You've got your phase-to-phase points of contact. You've got your ground wire coming up. You've got bonded hardware, so you've got some phase-to-ground points of contact as well. And so the solution here, again, is going to be some covers, dead-end covers on the center phase, and then covering the jumpers. And you can see this one is a little bit different configuration. But this kind of demonstrates what I was talking about before, how we have hose here. Now we do have a pin-type insulator where we had to have a little gap there where we tie it in, so we wound up having to put just a one-piece cover on top of that. And you can kind of see there's a little dead-end cover coming off down here. And then on the, this is probably underbuild, I'm guessing. We've got some covers on the tangent line as well. For new construction for corners can be a little bit difficult. And these are ones where you need to look at a number of factors. It's not just, I think a lot of times people think you throw a cover on, you walk away. I know when we talk to agencies, that's their perception. And yeah, if you could do that, but if you want it to last, it's not quite that easy. And so for corner designs, if you look at framing it out, this one they framed out the top arm, not the bottom though. But imagine you've got an 8-foot arm. You're going to lower that top arm 4 feet. Now you're going to lower the next one 4 feet. This jumper, you can see it's pretty long already. You're going to wind up with like a 16-foot jumper, and not something that crews are going to want to be able to work on. So you have to look at the safety issues also. You don't want to create a safety issue or a hazard for people working on the pole by trying to make it bird friendly. So one of the things that we've done in our standards is normally we try not to use covers for new construction, but we do have that as an option. So if, in areas where we don't want to deal with these long jumpers, we may just frame it out in the common position, have the cross arms up, and put covers on it. That makes it bird friendly, and then they don't have these really long jumpers to contend with. Another option that's shown in the applic manual is a vertical design. And even if you're framing out, you're going to need a really tall pole. Same thing with the vertical design. You're going to need a pretty tall pole for this. So this is probably something that's going to be more for new construction where you're planning it out and you have that pole height. So the other piece is steel and concrete poles. How many of your utilities are using steel poles or concrete poles? I know it kind of waxes and wanes. Are you guys using it for woodpeckers or for weather or price reasons? What's that? Strength. So are you using it just like on certain poles that have a lot of tension, or yeah, okay. Are you kind of the same?
We use some in woodpecker areas.
Okay.
Steel preparation.
So steel and reinforced concrete poles can pose electrocution risk because you've got a grounded pole, and particularly if you put a metal cross arm on it, and you've got a really high risk. So here you've got the structure is grounded, you've got your phase to ground risk. And to just kind of put it in perspective, within PacifiCorp, we've been doing surveys, we're in our 14th year now, where we hire biologists, they walk our lines and evaluate electrocution and collision risk, and we evaluate our product effectiveness, and that kind of feeds into our standards. And so we have a lot of data on what's worked for us, what hasn't worked for us. Overall, system-wide, we're primarily a wood pole system, and we average, again, it varies upon area, but maybe about 2% of our poles have electrocutions. There have been studies that APLIC has funded in Mexico where they've used concrete poles with steel arms, and they were finding electrocutions at 50% of their poles. So quite a bit of difference in the electrocution rates. If you have these in urban areas, probably not a big issue, or maybe you're going to have some starlings or pigeons on them, but not necessarily protected birds. But if you have these in areas where you do have bird habitat, probably worth taking a closer look at. So for solutions for this, again, cover, is one option. Another option is a pole cap, so kind of those plastic pole caps, and then a fiberglass rod to bring that conductor up a little higher. So basically you're preventing a bird from perching on here and giving it a little bit more separation to prevent contact. Three-phase, same idea. This particular example has a wooden arm or fiberglass, but it's still you've got phase-to-phase and phase-to-ground point of contact. And you can see here, this is a distribution line, and that's not that big of a bird. I mean, a hawk about this big. If that was sitting on the pole top, you'd have an electrocution pretty quickly. So you can see the risk on a steel pole. Solutions for this, again, quite a few covers, and basically on all three phases, and they use the pole cap and the fiberglass rod. And I'm guessing the reason why that's probably there is because even with the covers on, sometimes you'll get smaller birds that'll try to peck underneath the cover. And so if you have that right down there, you may still have some outages. If you bring that further up, you're going to prevent small birds from getting in and going phase to ground. And then I mentioned before equipment poles. Again, equipment poles are pretty high mortality risk compared to other configurations because of everything going on. So on a single phase here, you've got your phase to ground on your bushings. You've got an arrestor, so you've got the ground wire. You've got phase to ground point of contact just on that lightning arrestor. You've got your fuse cut out, quite a bit of energized pieces there, and then your jumper wires going up. So for solutions, it's going to be a lot of covers. And for equipment, cover really is the only solution that you've got. So we've got bushing cover on the energized bushing. All of the energized jumpers are covered. We've got a cutout cover and an arrestor cover. You move it to three-phase and it gets a little more complicated. So now, basically everything times three. And this one's a delta, so you've got, energized conductors here on the bushings. You've got your arrestors, still your cutouts, and you've got, three phases up top. This picture here, you can see these are grackles, which is kind of like a larger blackbird. But you can see the size here. Even small birds can be electrocuted on equipment poles just because of that tight spacing. And again, it may not be protected birds. These are protected, even though you may be surprised by that, but they are a protected bird. But non-protected birds, again, like starlings or house sparrows or pigeons, can get into this equipment and cause outage problems. And animals as well, raccoons, squirrels, that sort of thing. So solution, again, is a lot of cover. In this case, all of the bushings would be covered, all of the energized jumpers covered, 3 cutout covers, 3 arrestor covers. And the reason why you're covering all of these up here is because you've got that ground wire. So you don't need to necessarily cover the ground. Some utilities may do that, but as long as you're covering the energized parts around it. And then you also need to look at the top of the crossarm. Don't just look at the equipment. Look at, do you need a cover on the center phase up top? And here's an example. The transformer's cut out, but you can see some cutout covers, covered wire, and a center phase cover on that one. So next piece, I'm going to show you some pictures of the actual products. Keep in mind, these are not for human protection. Again, like I mentioned, they're not insulation. They are just cover-up products. They're not intended to be used for human protection, just incidental brush-by contact. Look closely at the manufacturer's instructions, because each manufacturer has a little bit different nuances. And if your covers are blowing off in the wind and you call the manufacturer, the first thing they're going to say, well, did you put them on right? And so make sure that you're following their recommendations. A few precautions. Again, buyer beware. There's a lot of manufacturers out there. Do your homework. Don't just buy 10,000 covers and put them up. Try out a few first, test them for a little bit, and make sure that they're not burning down your poles before you buy 10,000 of them. You want to look at what your local conditions are. Are you in a windy area? Do you have a lot of ultraviolet light that's a concern? Do you hot stick or rubber glove? How many of you guys rubber glove in here? Almost everybody. How many just hot stick? All right, your lives are easy. We hot stick a lot, so it makes things difficult. But that's the thing to consider. There are some products that you may not be able to hot stick, and so that can be a consideration. And then, do the covers fit properly? What insulator sizes do you have? As a utility that has merged over, I don't know, when you look at our family tree in PacifiCorp, we were made up of like 100 different smaller utilities over the past 100 years. And so our standard is that there's a lot of standards out there. And so we don't have one set insulator size. We've got 1 million of them. And trying to find a size fits all cover is pretty much impossible for us. And I don't know if, if other utilities struggle with the same thing, but trying to find a cover or make a cover fit, you may be creating problems. So you want to make sure that they fit properly. And again, do some quality control and work with the manufacturers. They're pretty open to meeting your needs. If there's a cover that doesn't exist or you're having problems with one of their covers, let them know about it, and they'll, step up to the plate hopefully and be able to help you work through it. So for insulator covers, this is probably one of the most diversified different types of products. There's a lot of different types. You can get 1-piece, 3-piece, tangents, single pin, double pin, different insulator sizes. A lot of manufacturers will make these tangents 1-piece, 3-piece. Once you get into angles, side ties, not as many. And if they claim to, again, do your homework because some are going to be better than others. See what works in your situation. Here's a few examples of different types of insulators. So here you've got a small size, here you've got a larger size, and these are all tangents. Here you've got a post insulator. This one is a clamp top insulator. These are all different types of covers. For angles, there's different manufacturers. Some manufacturers have a more soft product that'll mold kind of to an angle. Others are more rigid. These here are a little hard to see, but they actually flare out on the sides, so it can accommodate an angle. Angles are tough. And so really, again, look at the products, especially if you're in a windy area. If you have a side-tied angle, I would put them out through a season of the wind and see if they hold up, because we've done that, and we've had to replace a lot of covers, that didn't hold up. How are they reinforced? Some covers may have an internal locking mechanism. Some may have external pins that you have to push through. Some may not have anything like that. And so again, when you're looking at wind and conditions, what do you need in your area? If you have a double pin, will it fit? Is it small glass? Is it larger glass? How far apart are your insulators? Some covers can accommodate some change. Some are really fixed, and so you may have to cut them or tweak them to fit. Some manufacturers, you may be able to cut their covers or drill holes in them and kind of custom fit them. Others you may not. And so talk to the manufacturer and make sure that it's okay to modify their covers before you start going out and doing that. Proper installation, again, is key. If they have extension arms, you want to make sure that they're attached properly so that they don't slide off. How many of you have put up an insulator cover and seen the arm down the line mid-span? Anybody? No? All right, you guys are good. But that is something that can happen, and so you want to make sure that they're installed properly to begin with. And again, if you're having problems, even though they were installed properly, what's going on? Take pictures, take the product back to the manufacturer and see what the issue could be. So dead ends, I showed a few examples before, and kind of the idea behind it is, even though this isn't a dead end, this kind of shows how a bird may land on a pole. So when they're landing or taking off, their wings are still outstretched. And so you may have a bird make contact not on the crossarm, but while they're still kind of in flight. And that's why you want to bring that center phase out. And so here's a few examples of dead end covers. This is one that's not even a dead end cover. It's a large bolted dead end shoe. And we didn't have any cover to fit that. One of the crews in the area just took one of our existing tangent covers, cut it, and made it to fit. And so there may be things that you have to do like that. It's probably, for the number of these that we go through, it's not worth the manufacturer's time and expense to mold a whole new cover, so we try to find some homemade solutions. Regardless of the type of cover you use, the key thing to remember is that these covers should not cause additional problems. They're meant to solve problems, not create problems. So if they're creating problems for you, you need to go back to the drawing board and figure out why. One of the things you need to look at, whether it's an insulator cover or a bushing cover, you should not be covering the entire insulator or the entire bushing. You basically want to just be covering the top black semiconductive part, because you still want to make sure your insulator can wash off. If you cover this whole thing, you've basically just created a path to track to the crossarm. So again, making sure that these things are installed properly and training crews so that they know this in the field is important. Here are some examples of failures. This is an insulator cover with some tracking on the inside of it. Here's a bushing cover that was installed, probably a little too far down and tracked over. So these are some of the problems that you could see with products. And hopefully not. And hopefully I'm not scaring you with some of the problems, but I think going into it, from some of the lessons learned that we've had doing retrofitting, you know, just do your homework first, make sure that products are installed properly. Probably 9 times out of 10, we don't have problems with products. And once we identify ones that do work well, you know, they're working fine. But kind of getting over, you know, some new products or some changes, you know, it's important to test them properly. And if any of you are members of like NETRAC did some testing on bird and animal protection products maybe about 5 years or so ago. So there are some reports that give testing results for various products. Perch discouragers, which are kind of triangles, spikes, were used a lot in the 70s, 80s, and even into the 90s. And the idea was that you would discourage a bird from perching in an area where there may be an electrocution risk and give them a safe place somewhere else to go. They were not intended to eliminate perching completely on a line. There's different types. There's triangles. This is a little hard to see, but there's spikes here. There's different cones. Perch discouragers are a little tricky. It's hard to get them to work effectively because basically you need to have separation between the discourager and your conductor. So depending on your voltage, you know, you're going to have a certain distance that you need to keep there. For them to be effective and not have a bird squeeze in next to them, you don't want to have more than 5 inches. So those two numbers can conflict, and so discourager may not work. The other thing that they can do is they can push birds to equipment. So if you have equipment below and it's not bird guarded, you may be creating more of a problem than a solution. They're great for building nests on. They hold nest material on really well. And as you can see, birds don't really, you know, avoid them. They can actually make this particular design. The top is cut off, but this is an avian safe structure. We've got 60 inches separation. These were put up in an area because of sensitive species, and we get a lot of, especially in the West, and if you guys are dealing with prairie chickens, you may see this where you have to put up discouragers to keep raptors from preying on the sensitive wildlife. Well, you get an eagle perched on here, and all of a sudden you've effectively lost your 60 inches, and we were killing eagles on raptor-safe structures because of this. So some of the kind of unintended consequences. Some of the spikes also, you could get workers' clothing stuck on them. Birds have gotten impaled on them. Just, there's a lot better solutions out there now than the discouragers. Perches are another one. Were used quite a bit in the past. They don't make a structure safe. They may be used near a nest site, but then you also have to consider contamination from excrement that may come down off the perch as well. And an important thing to consider, a lot of times people think, oh, just fix the crossarm, they go on the tallest part of the pole. Not necessarily the case. You know, they could go anywhere on a structure. And never say never, because once you think, oh, they're not going to perch on this particular part of a structure, they will. And if they want to be on that pole, they're going to find a way to be on there. So really, if you're going to spend the time and resources to send a crew out to bird guard a pole, you might as well look at doing it completely while they're there. Bushing covers, again, you want to just make sure you're covering, the top skirts. There's different styles. There's clamshell type clamp-on styles. There's rubber style. Again, evaluate, you know, what meets your need in your system. Arrestor covers, same thing. And really on the arrestors, you want to make sure that you're covering all of them if you've got 3 of them because of the ground wire. And you can see here we've got some gaps in the covering. Not necessarily the best thing because you've got a gap there and a gap there. You spend a lot of time putting a lot of hose on here. You still have potential for an outage or an electrocution there. Some utilities may cover the ground wire underneath. You know, not necessarily necessary, but it is, you know, a little bit added assurance in a congested area like that. And then cutouts, cutout covers again. If you have cutouts and arrestors, you're going to want to cover all 3 cutouts because of the point of contact with the arrestor grounds. If you just have cutouts and no ground wires up there, you can just cover the center cutout like you would the center phase on a crossarm. When you look at cutout covers, you want to make sure if you use a load break tool that they don't interfere with the operation of that. And there may be some covers, you know, hopefully the ones that are out there now do not. Some of the earlier generation had some issues with that, so that would be something to look at. And then switches. It's very difficult to make a switch raptor safe. You can't put any cover on there. You have moving parts. This is probably the closest that you're going to get to an avian safe switch. You still don't have the 60-inch separation, but it's inverted. It's underhung, so it's going to be a lower risk if a bird does come in there. You know, they're not going to be perching down below on the switches, and this is covered wire leading into it. We've used these for a few years now in our company, and the crews actually really like these switches quite a bit. So they've worked pretty well. And then hose, there's a variety of styles, different sizes. You can get hose from 1/4 inch up to like a 4 or 5 inches for a substation bus. There is split hose and there is solid hose. If you are, and it looks like most of you don't hot stick, but there is a hot stick application tool for split hose that you could use as well if you needed it. The one issue with hose is unless you cut it perfectly, like that picture I showed you before, you have a pretty good risk of having some gaps. You know, if you're eyeballing it on the ground and then installing it, you may have some gaps in coverage. If you're using covered wire, that's going to effectively reduce that risk, because covered wire is pretty hard to skin. Nobody's going to skin an extra 6 inches off covered wire. It's just too difficult. So this may be a good application, particularly for new construction. Rather than having to purchase hose and covered wire, or excuse me, hose and bare wire, purchasing the covered wire may actually be less expensive. For a retrofit, either one may be feasible, and again, kind of look at cost and what's appropriate for your area. These come in a variety of sizes, solid and stranded. What we found in our area, we do have a lot of wind. We've gone to the number 2 stranded because we've had a lot of problems with the smaller sizes breaking. And when you're stripping it, if you strip it with a knife or if you have a tool to strip it, that can also influence your breakage, because with a knife it's a lot easier to nick it. And once you have just a little nick in there, that's going to vibrate over time and that's going to snap off. And especially if you've got a bushing cover on top of that, you may not even see that it's snapped off. So using the tools works pretty well. The tools, you may have to have like a separate tool for each size if you're doing, using different size wire. But they seem like they're certainly worth it in reducing problems. So that's it on the electric distribution piece. We'll go ahead and take a break. I guess if anyone has any questions before, or you can come up after during the break and ask me. All right. Thanks, everyone.